Okay, so let's see if we can try and figure out some basic characteristics of quadratic, including the axis of symmetry. So we're going to kind of go through this, and then we'll figure out a bunch of the characteristics once we kind of look at it, and the important characteristics that you should really be thinking about. So I have the equation 2x squared minus 4x plus 6. I guess that's an expression of an equation. So let's add an equal sign to turn it into an equation. Okay, now that I have the equation, I didn't really need the equation before, but just for the purpose of some of the stuff we're going to do. I have this negative b over 2a. This is the formula to calculate the axis of symmetry. And what is the axis of symmetry? Well, it's a line that goes on a parabola. So let's graph the axis of symmetry. In order to do that, we need to be able to think back to ax squared plus bx plus c and find the a value, the b value, and the c value. So the a value is 2, b value is negative 4, c value is 6. Again, these are just some things you should know, and using this formula I can just plug these numbers into the positions. But errors occur, and I'm going to point out where the majority of errors will occur by rewriting the formula in a format that will help you prevent yourself from making those errors that some of my students make. If b is negative 4, when we plug it in, we want to include the negative sign, and because the formula has a negative, a lot of students will leave it out because they won't include parentheses. And then I'm going to plug in a value of 2, and so that gets me to negative 4 times negative 1, which is positive 4 over 4, which gives me the value of 1. So x equals 1. Okay, so what does that mean? So it means that if I have a graph, I have at 1, we'll kind of put it far away, at 1 I'm going to put a dashed line, a dashed vertical line, okay? And so the axis of symmetry, this idea, is going to be a line of reflection. This is a line of reflection, and it's a vertical line, okay? It's a vertical line. So you can think of it as a line of reflection as a vertical line, which means that somewhere on this line I'm going to have my vertex of my parabola. Alright, so basic characters of a quadratic. Maybe some of this language is new. So what is a parabola? Parabola is a curve that looks like this or like this, and we can see them going up or down, and they can get wider or narrower. They do not go side to side, and there's reasons for that. I'm not going to get into it. Now, back to the standard form, each of these letters, A, B, and C, those letters have purpose and meaning. So for instance, the A value, right, these are characteristics. The A value tells us which of these directions we're facing, if we're facing up or if we're facing down. How does A tell us that? If A is positive, we face up. And if A is negative, we face down, right? We're sad, we face down. I guess you probably heard that before. Happy, we're positive, we face up. So that's kind of like a frown and a smile kind of way to connect it. All right. So we know that this parabola should be facing, based on the value of 2 being positive, it should face up. And now I know that I have a vertex, which is going to be the point that is the highest or lowest point, and we call them maximums or minimums on the curve, right? So I have some information already using this axis of symmetry. I know like this line, which if I drew it right down the middle of this, you can see if I could fold the paper where this line I'm kind of drawing, which is kind of light, this piece would flip over and it would just map perfectly to itself, and that's why we call it a line of reflection. The left side will flip over and map to the right side, or the right side will flip over and map to the left side, one or the way or the other. So where on this line do I have this point? Because it could be anywhere, right? Well, it can't really be anywhere. The equation determines that. And since I know that a vertex is an ordered pair, right? It's some x, y value, and it's going to be on that line. The value of 1 is part of the vertex, okay? It is the x-coordinate of the vertex. So what that tells us is that the value, the axis of symmetry, is also the x-coordinate of the vertex, which is useful information. So how do I find the y-coordinate? Well, I just take the x-coordinate and I plug it back into my equation. I'm doing it way down here just because it's there's no room up there. But I can always exponents first in this situation. So 1 times 1 times 2 is just 2 minus 4 plus 6. So 2 plus 6 is 8. 8 minus 4. So I will have y equaling 8 minus 4, which is 4. So my vertex is at 1, 4. So if I kind of add some tick marks to my graph, I have a vertex right there. I'll put 1 there, I'll put 2 there. All right, so I'll add just another tick mark. So I know that the graph opens up from here, but how does it open up, and how do I go about finding another point? Well, the C value is also another important characteristic. It is what we call the y-intercept. And if you remember back to slope-intercept form, we had a y-intercept that was the constant in that equation. So the constant is the y-intercept, the value with no variable. And so that means that at 6, I have an additional point if I'm on the y-axis, right? So so if I think about the idea of this parabola being a curve, that I can kind of think that this is going to curve up then through those 2 points. Okay, well, where is it going to sit on the other side? Since this is a line of reflection, let me just draw that curve a little bit better, just because I want it to look as best as I can. But because this is a line of reflection, I know that this point is going to go to this line. How many units does it take to go horizontally? Well, it's just 1 unit from 0 to 1, which means that I'm going to go just 1 unit over, and I would have another point right about here, and they are equidistant from this curve. And I'll put the other side of this, and so it's going to kind of go up like this, right? It's going to go up like that. So we can see if I continued this line, this reflection, this orange side would map over the green line and map perfectly to the purple. But when we deal with quadratics, we really don't want to limit ourselves to just 3 points. 5 points are really good, because 3 points could be confused for an absolute value function or some other function. So we really should use 1 more point, and we should get it on the graph. So how can we kind of do that? So I'm just going to kind of box this in. So we can really just kind of look, and we used 1, we used 0, and we used 2. So we could actually just use 3. What do I mean by that? Well, let's build an input-output table, right? X and Y. I know 1, 4 are values, and I know 0, 6 are values, because I have these points. I also know 2, 6 is a value. So I'm going to reorganize these so that I have the vertex in the middle. Okay, and it's helpful to see it that way. And I'm going to go 0 is on the left side, and then 2 is on the right side. So now we can kind of see a pattern. So I'm going to go 1 more over from 0, which is -1. And where on my graph would I be? Well, we can just plug -1 into the equation to kind of find that. And I do the calculation. This would be 2 plus 4 plus 6 would be my value of y. So y would equal 12. And so now I know that if I plug in -1, I'm at 12. So at -1, this is 6, 7, 8, 9, 10, 11, 12. I'd be somewhere way up there. So my purple line would still have to kind of keep going up till it went through that point up there. You know, and then of course we would have a line reflected across the axis of symmetry, and this is getting a little messy, but that means it would be on this side. And you can kind of see, if I continued this orange curve right here, I would have another point approximately here, which should be at 12 and 1 further unit over. So 312, and it's just going to be mapped, right, equidistant if this is the vertex, and this is the y-intercept in our table. All right, well, that is kind of just the quick way of kind of going through a lot of characteristics through thinking about it. And then we have some end behavior of our quadratic. This is often misunderstood. And what it's saying is as x increases, right, we have to figure out what does y do. And as x decreases, what does y do, right? And those are the kinds of things that you have to be able to understand. So we kind of want to look at the graph and say, all right, well, let's go to the vertex. And of course, x is right here, and this is y right here. So if I go from my vertex and I read as x increases, that means like I'm going to the right, right? Because from 1 to 2, 2 to 3, these are increasing. So if I go to the right and my x values increase, do I go up to get to my graph or do I go down? Well, I go up, therefore y must be increasing. And if I go the other way, right, from the vertex, I'm going down, so I'm going from 1 to 0 to -1. To get to my graph, I still have to go up. So as x decreases in this situation, y is still increasing. So as x increases, y increases, but as x decreases, y increases. These are often made terrible errors on these simply because we don't really take the time to fully grasp the simplicity of them just by thinking of that relationship of direction. So I'm not going to go through this next one super slow. I'm just going to go through it fast. So how would I do it? I'm going to use x equals negative b over 2a, just so you see how fast you can do it. If I plug in 6, I plug in 1, right? So I didn't identify 1, 6, and -4, but I have it, and this equals -6 over 2, which is -3. So x is -3. So I know that on my graph, I have at 1, 2, 3, I have my axis of symmetry right there, and somewhere on that line is my vertex. So my vertex is -3 comma some number. So I'm going to plug in -3. I'm going to square it, plus 6 times -3 and minus 4. Well, this is now 9 minus 18 minus 4. So -13 would be the value of y. And I'll keep the y there just so we see it. So at -3 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So we would be way, way, way down here. This would be our -3, -13 location. And now we also know that the y-intercept is -4. 1, 2, 3, 4. So this is getting a little messy because of the tick marks, but the idea, this is right here, 0, -4. And so I could draw my curve kind of like that, and then I can reflect across this line. So I went 1, 2, 3 units, so 1, 2, 3 units. And I'd be on this side, and there would be the other side of the curve going that way. But I have 3 points, and really I want to get more. So I could really kind of look at anything I wanted. I'm going to use 1, just because 1 is kind of an easy number to plug in. And since I don't have a point beyond this value, it's a reasonable one to choose. So I'm going to say 1 squared plus 6, sorry, I put the parentheses around the 6. It should be around the x value that I'm plugging in, minus 4. So 1 plus 6 is 7 minus 4. So that would be the y value, right? So I would also have this is the vertex. The y-intercept is 0, -4. And I know that I have another point at 1, 1, 2, 3 right here. Look at that. It's actually pretty much right on the line, and there would be a reflected distance across the line, and it would be about here. And we could say that this is 1, 3, and of course this is at -3, so -4, -5, 6, negative 7. So this would be what, negative 8, 3. It looks like that would be negative 7, 3. Sorry, negative 7, 3. I have too many tick marks. But it's a sketch, so the point behind it isn't about the location specifically. Of course, the location is important, but it's about the idea of how you kind of get from here to here. This would be kind of that same distance horizontally each time we move up vertically from the line of symmetry. So I now have, if I kind of just put an XY table, and it's always useful to put your vertex right in the middle because then you can kind of see how numbers look in relation to it. So I have this negative 3, 13. This is negative 3, so negative 4, negative 5, negative 6, negative 4. So I have negative 6, negative 4, but I also have 0, negative 4. And then I have 1, positive 3, and I have negative 7, positive 3. And why can we look at this table and kind of see some things that are important? Well, we can see that I went 3 units this way and 3 units this way, and I should go the same number of units in both directions, and these numbers should always kind of reflect that pattern. So that's just kind of a breakdown of characteristics connected to the graphs. Of course, we can look at the end behavior of this parabola as the same as the end behavior of the other parabola because they're both doing the same thing. They're both moving to the right and up, or to the left and up. The vertex and the axis of symmetry, pretty straightforward to find. The only other things you might kind of want to recall are kind of domain and range, but we'll save those for other videos.